A quantum mechanical interpretation of an equation of state parameter of unity for matter. The equation of state for fluids with quanta that have a rest mass and zero self-interaction energies, i.e., perfect fluids of matter and space, is given by where the asterisk superscript denotes a single quantum intrinsic property and n denotes the number of quanta. Taking the single quantum limit of the above equation and then dividing both sides of this limit by m*(C2) yields where the equation of state parameter for matter is in the range 0 omega less than or equal to 1 and for space fluids omega equals 1. The entropy for a space fluid quantum S** is equal to the Boltzmann constant, Kb, which when substituted in the previous equation gives the ideal gas equation as shown below. Hypothesis: it is proposed in this study that the omega-1 limit of this expression describes the state of a real, classical particle at its maximum temperature and pressure conditions. At these maximum conditions, virtual matter-antimatter pairs of this same particle are created as vacuum fluctuations. The original particle is then rapidly annihilated by a virtual antiparticle. Listed below are three limiting temperature curves that describe particle rest mass energy equals wave energy, omega equals 1/chi is almost equal to 0.2. Relativistic matter particle behaves like radiation, omega equals 1/3. Particle rest mass energy equals the kinetic energy, omega equals 2/3. These high temperature limits for real matter particles will lie within -0.7 log units of the omega equals 1 line shown below in the log temperature versus log density figure. Given the 60 orders of magnitude covered in the next figure, these other omega lines for maximum temperatures would appear very close to the omega equals 1 line in the figure. Matter BEC phases define a low temperature limit on atomic fluids. All matter particle masses are greater than about 10 to 38 kilograms. Only radiation quanta have masses below about 10 to 38 kilograms. Quantum, classical particle boundary of omega equals 1 for temperature. All fundamental fermions and bosons with mass as well as the space fluid quanta can be represented in this figure. In the next figure for the log of pressure versus the log of mass density, the omega equals 1 line is the boundary between behavior as a real classical particle versus behavior as a virtual particle pair. Pressures and densities of neutron star cores, the electron degeneracy curve for white dwarf stars and the conditions for the quark-gluon plasma all lie close to the omega equals 1 line in the next figure. Quantum, classical particle boundary of omega equals 1 for pressure. All fundamental fermions and bosons with mass as well as the space fluid quanta can be represented in this figure. In the next figure for the log of pressure versus the log of mass density, various cosmological environments are plotted to illustrate that the omega equals 1 boundary applies to all matter systems. There are no galaxies or clusters of galaxies that occur at pressures and densities above the omega equals 1 line in the figure. These cosmological environments plot near the Piro conditions of interstellar gas clouds. The dense and high-pressure cores of planets and stars also do not exceed the omega equals 1 limit. Note that matter fluids have a high-density limit curve defined by the conditions in the cores of planets and stars. White holes start at the Planck fluid and end at the vacuum, while Piro paths for collapse of stellar black holes start near the neutron star core conditions and end at the Planck fluid. Log pressure versus log mass density for a universe system. Universe pressures have radiation values from initial to CMB time. The phase diagram for space fluids versus radiation in matter. The pressure energy density temperature phase diagram for space fluids has 0 degrees of freedom. Pressure energy density temperature are a fixed point for a space fluid. The pressure energy density temperature phase diagram for radiation fluid has 1 degree of freedom. Fixing temperature fixes pressure and density for radiation. The pressure energy density temperature phase diagram for matter fluid has 2 degrees of freedom. Both temperature and density or pressure must be fixed to specify the state of a matter fluid.